Hey everyone, and welcome back to this explainer brought to you by Forge College. It is absolutely fantastic to have you with us again. Now, if you hung out with us for the previous lesson on using filtered event data, you know we covered how to neatly aggregate filtered events to, cut through all that downstream noise. We learned how to use index parameters to perfectly slice and dice data for off-chain consumption. But here's the catch. Filtering is an amazing tool for reading data, but what happens when you're the one producing it? Today, we're diving deep into scaling event emission and log management as part of our Solidity from Zero track. We're going to look at what actually happens behind the scenes when you emit those events, and way more importantly, how to stop them from completely draining your wallet.
Okay, let's just get right into it. Have you ever stared at your smart contract's gas consumption and asked yourself, why in the world are my events burning so much gas? Well, I kind of have to drop a bit of a bombshell on you here. While filtering is fantastic for reading data, writing all of those incredibly verbose logs on chain is quietly bankrupting our smart contracts. Seriously, emitting highly detailed events for every single tiny action, even if you index all the right fields, consumes massive amounts of gas and just balloons your on-chain log footprint. The filtering pattern we learned earlier is highly effective for consumers, absolutely, but it totally ignores the crushing financial cost of actually producing those logs in the first place.
So we need a real engineering blueprint to fix this expensive logging problem. Today we'll hit 4 quick topics: the gas guzzler problem, the anatomy of event costs, the compact batch pattern, and finally, the scalable logging workflow. Let's kick things off with Section 1, the gas guzzler problem, or as I like to call it, shipping single grapes.
Picture this for a second. Imagine you run a shipping company, right? And you have 10,000 individual grapes that you need to send to a grocery store. The naive approach would be putting a single grape into its own massive, heavy-duty cardboard box, taping it all up, printing a separate shipping label, and paying full price for that one box to be shipped. And then, doing that 10,000 times. It sounds insane, but that is exactly what a naive per-item emission loop does in Solidity. You iterate through an array of items and emit a full, heavy event for every single one. It is incredibly expensive. Now contrast that with a compact batch approach. Instead of 10,000 individual boxes, you take all those grapes, pack them tightly into a single, highly efficient sealed crate, print one shipping label, and send it. One transaction, one log. Massive gas savings.
To really grasp why the grape-in-a-box method is such a disaster, let's move to Section 2, Anatomy of Event Costs, focusing on topics versus data.
When you write to the blockchain, what are you actually paying for? Well, your event data is split into 2 distinct categories: topics and data. Topics are your indexed parameters. They're stored using Bloom filter fast checks, which makes them lightning fast to search and filter off-chain. But that speed comes at a high premium. First off, you have a hard limit. You can only have 3 non-signature indexed topics per event. That's it. Second, every single time you create a log, you pay a base overhead just for those topics. So if you emit an event in a loop 10,000 times, that topic overhead multiplies 10,000 times. On the flip side, the unindexed data portion of your event is significantly cheaper to store on-chain. It can hold a ton of information, but the trade-off is that it can't be quickly searched by your nodes. So what's the takeaway here? We have to be highly strategic. We must fiercely protect our 3 indexed topics, using them strictly as primary search keys, and then push absolutely everything else into the cheaper data payload.
Which brings us right to our practical solution. Section 3, the compact batch pattern, or pack in the crate.
So, how do we actually structure this compact batch event? Instead of listing every single item ID and value in separate events, we consolidate. We might set up an event where we only have one single index topic, the operator. That becomes our primary search key, making it super easy to filter logs by whoever initiated the action. Then, to represent the whole batch of items, we'd use a start ID and a really compact integer, like a uint16 for the count. We know our batch sizes aren't going to exceed what a uint16 can hold, so why waste the space, right? And finally, the absolute magic ingredient, a byte array for the packed values. This single byte array holds the actual data for all the items processed in the batch, completely replacing the need for a massive array of individual logs.
And how exactly do we generate those packed values? We use a beautiful little Solidity function called abi.encodePacked. What this does is produce a tight binary representation of data for highly efficient on-chain storage. See, normally Ethereum pads data out to 32 bytes, which wastes a ridiculous amount of space if you're just storing small numbers.
But abi.encodePacked strips away all that padding. We use it to seal all our array values super tightly into one single binary blob. We're literally replacing a giant array of individual expensive logs with a single tightly packed payload. Like I said before, it is the ultimate crate for our grapes.
Now, you know as well as I do, engineering is all about trade-offs. If you stick with a naive per-item event, sure, you get high searchability because every single field is directly accessible, and it requires very little off-chain work. But your on-chain footprint, and therefore your gas cost, is astronomically high. Switch over to a batch event, and boom, you drop your on-chain footprint down to low. You save an absolute fortune in gas. However, you do trade searchability down to medium, since only the operator is indexed, and you shift the off-chain work to high. Why? Because now your off-chain indexer has to take that tightly packed binary blob and deterministically unpack it to read the individual items. But honestly, you are trading a bit of off-chain computing power, which is dirt cheap, to save on-chain gas, which is very, very expensive. It's a no-brainer.
All right, let's zoom out and put it all together. Section 4, the scalable logging workflow, our blueprint for scale.
Here's your 4-phase blueprint for scaling. Step 1 is design. You gotta be ruthless here. Choose only 1 or 2 primary search keys to mark as indexed. Usually this is an address or a contract identifier. Just keep your non-signature topics under that limit of 3. Step 2 is emit. Use our compact batch pattern. Implement a single emission per logical operation, using abi.encodePacked to shrink that payload down, and use bounded integer sizes for counts. Step 3, index. This happens off-chain. Your listener needs to catch the event, use the index topics to quickly filter candidate logs, and then unpack that tight binary blob using deterministic decoding rules. And finally, step 4 is archive. On-chain logs are immutable, but off-chain? You don't need to store every raw byte forever. Keep a long-term compact index keyed by those topics and timestamps, and just prune the raw packed payloads if you don't need the absolute granular history. It'll save you massive database storage costs.
Listen, if you take away absolutely nothing else from this explainer today, let it be this core philosophy. Think of on-chain logs as the durable headline, and off-chain storage as the archive of full details. Your on-chain headline needs to be short, punchy, and highly searchable. Basically, who did what and when. That gets the attention of your indexer. Then, the off-chain indexer takes that headline, unpacks the tightly wound data, and pieces together the expanded story for your application's front-end or analytics dashboard. It's just a beautiful, highly efficient division of labor. And there you have it. That brings us to the end of our blueprint for scaling event emission. Your mission now? Go review your own smart contracts. Seriously, go find those naive loops, pack those crates, and stop burning gas on single grapes. Before you jump back into your code, just ask yourself, what other hidden gas guzzlers are quietly lurking in your code base, just waiting to be batched? Something to think about for sure. Now, in our next explainer for the Advanced Event Handling Techniques module, we're going to build right on this foundation with Designing Events for Reliable Interaction Monitoring, where we'll look at producing deterministic behavior and minimizing false positives in your alerting systems. As always, this explainer was brought to you by Forge College. To dive deeper into this subject, grab the code snippets we talked about, and explore tons of other amazing Web3 topics, make sure you visit forge.college. Keep building smart, keep optimizing, and I will see you in the next lesson.